Hello, I'm Dallas Campbell, and in this series of videos we're going to be showing you how to become a citizen scientist, how you can take part in real scientific experiments and help researchers make genuine discoveries about the world and the universe beyond. Well, today I have come to a rather damp breaker's yard in southeast London to try and understand how dented cars can tell us all about warping in space and time. To help me, I'm joined by Andrew Davies from the Open University. Why on earth have you brought me here?
So for my PhD project, I've been looking at warps, and warps are caused by mass in space-time. We're looking for arcs, which are warped distant galaxies caused by the mass of a foreground galaxy warping or distorting the space-time to give rise to these images.
So what's the link between that and say, a dent in a car door like this one?
So car companies may use similar technology, artificial intelligence, to look for these warps or dents in the car body to try and infer the damage on the car based on those images and the warps they find.
Okay, so the AI will look at a car panel and go, oh look, there's a dent in it. But I can look around and use my eyes. I mean, I can see there's a great big dent in this car, for example. Could I look at your pictures from space and see warping of space-time?
Yes, you can. So we have simulated images for the Euclid telescope, which you can actually see with your eyes, these arcs or distortions or warps in space-time.
What's better, an AI, machines or humans?
This is exactly what the Citizen Science Project is trying to learn. We have AI technology which has already looked at these images and we have scores for them. Unfortunately, we haven't got scores for humans.
Well, our citizen scientist, Alice, is doing just this. She's looking at some of your images.
Right now, I'm looking at a gravitational lens, which I found on Euclid Challenge the Machines. In the middle is a bright yellow core, bit of an oval. Around that is a lovely ghostly bluish-grey ring. Now, the reason that's formed is we've got a galaxy relatively close to us, like this, and behind it we've got another galaxy. The light from this other galaxy behind us, it can't go through that yellow one in front, it's blocked. However, light can go sideways, it goes out in all directions. So it went out like this, then the gravity from this one pulled it in again, so it went like this. Now imagine it happening all around that, and that's what gives us this beautiful ring. It looks fantastic. So I'm trying to find anything that looks like this. It might not be the whole ring. If the galaxy wasn't completely lined up, then you'll just see a little arc or a little patch. You get to know after a while which is a lens and which isn't.
Once you've got this data, once you understand it, what's the point of it? Why do you need to understand this in the first place?
Well, the point of this is to learn why the machines are better and how we can improve them for future missions.
So is this more of a project about machine learning rather than astronomy?
Yes. So we want the technology to be able to scan through millions and billions of images so that for future space missions, when we have all this data, we don't have to look through them painfully.
So this whole project is about seeing what is best, computers versus humans. So if you were a betting man and you weren't running this project, where would you put your money?
My money would be on the machines to outperform
Really?
the humans.
Have you met Alice? She's good. She's working very hard. I'm going to put a tenner on Alice. There are loads more citizen science projects you can take part in, from penguin spotting in Antarctica to helping rescue teams target aid and resources during natural disasters. Find out more on the Citizen Science website.
Get more from the Open University. Check out the links on screen now.